we are doing mobile distributed computing, we are talking about um who now is the what is the name? The one from code, the monitor, is he or she here?
Is it Lizzie Lisbeth?
The name I don't know, but the person should be here. Should be here, and I'm asking if the one is here. No one is responding.
Sir, please do the course record.
No. Actually, I called her, but she's not picking up.
You call her, she's not picking up.
Yeah.
Okay. So where is she? And then she's sitting somewhere and she has started recording. Right? Hello, can you people hear me?
Yes, sir.
Hello.
Yeah, we can hear you,
Yeah, we
sir.
can hear you.
Okay. Mr. Bernard, I think I
Sir.
mentioned that we have 6 units, and each unit is made up of 6 sessions from the word go.
Yes.
So here we are. This week we are taking off with Unit 2, Session 5, where we are looking at edge computing architecture and framework. Now, when we talk about framework, normally we need framework to enable us come out with what we want to do and as to when to do it. So here, today we are starting it with the edge computing architecture and framework. Please, can you see it? Is it on your screen?
Yes, sir.
Okay. So edge computing architecture and framework. When we talk about edge computing architecture, we have various forms. Then the edge, as we are mentioning. Earlier on, you had a picture that when we take a network, we have the core, the edge, and then the end users. So, talking about the edge, how is the architecture like? How is it designed? So we have one which is centralized. We have several, quite a number of them: central edge, distributed edge, etc., etc. Quite a lot of them. We will discuss some few of them, and the rest you follow up with. Now, when we mention the centralized, in this case, data processing normally occurs in a centralized location and often referred to as an edge data center or regional data center. Edge, I think, let me have edge or regional data center. Now, most often this is required for applications with low latency processing. Low latency processing. And it's employed in vehicles automation, in the industrial automation. I believe we all know what is latency, more or less delay between the sender and then what they call it, the recipient. So this, the name as it tells you, it's actually have a centralized what? Location. A single centralized location. And this is where all processing are done. So you can query and the processes is done over there. Now we have the other one, edge architecture. In this case, the edge architecture disperses resources across multiple locations or devices. Now, which are these devices? Most often they are servers. And then enabling local data processing and also reducing data transmission to a centralized data center. So you see, in the case of the centralized, everything is done over there. However, in the case of distributed, it doesn't necessarily mean, or what it means, what it presents is, you can have this information distributed around the world with all these devices sitting around the globe, not at one point. In the case of centralized, yes, at a location, a single location. They are how they call distributed. The word itself tells you distributed. You see, and then you have the various information on them. That's reducing data transmission to a centralized centralized data center. Mostly, this started or it's applicable with the IoT content delivery. Now I'll move to the next one, for computing. Now this one deals with what we term as the cloud computing, but its capability is that it extends the cloud capability to the edge. It extends it from the cloud to the edge. Why to the edge? In this case, it assists or help in reducing going further. That is the distance from the core. In this case, it also reduces what? Latency. It reduces it. So when you talk about healthcare services, smart cities, etc., this is where it is employed for what? Computing, which actually extends the cloud closer to the users or closer to the network edge. You and I already know that we are connected to the edge. Whatever is happening there, closeness or farness, it's the edge we are connected. But here's a case. What we're saying is that the fog actually extends whatever the cloud contains to the edge. We have decentralized edge computing. The first one was centralized. We also have decentralized edge computing, hybrid edge cloud architectures. These I detailed you to go a bit detailed into them. They are just, yes, scanty here, summarized as I gave you in the material or as the material was given. Now let me find out, did I give you the material or it was the, you downloaded it from the system? Hello, hey, are they there?
We are there.
Oh, hello. Yes, Madam Cost, Assistant Cost Rep. Emily. Emmy?
Yes, sir. Yes, sir.
You have the material. You have the materials, right?
Yes, please.
How did you come by it? Is it from me or
It
from the
was
system?
It was from the module link they shared to us.
Okay. And have you compared it with what I've been using to make sure that we are on the right frequency? Hello.
I can't really say because I've not opened it. I do go with yours. I can't really say, sir, because I've not opened the one they gave us. I've always go with yours.
Why haven't you been able and you've not reported or have not found out from your colleagues? Anyway, let me go on.
No, it's not
Let
that
me go.
for myself.
For yourself. Yes, I'm saying, so it means time. It's as a result of time, right? You have never been able to go
Yeah.
there. If I did get you right. I like
I've
your
been able to go there, but I've not really opened yours.
it's mine rather, right? Okay, let's go on. But what I expect is that after lectures, whatever you jot down, you have to go to the material to read. Or did I also send one to you? Madam Emily,
No, please.
have I also sent?
No, please.
So what
So
you
if you
should
can help us.
is the same thing. There's nothing like helping you. All I want you to do is that as students and wanting to, you see, you always go for material and you dump them, you pack them, pack, waste data, waste everything. All what you need to do is, after this, for example, you see here 5.1.2 is edge computing framework. You go there and find out if that is it. But you see, all what you are saying tells me that even that, if you have downloaded it, you have not gone through it. You have not gone through it. Okay. So we go on to the next slide where we look at edge computing application and use case. We've mentioned some few of them. We've mentioned some few components of them where we made you to understand IoT, etc., etc. Now here you have application and use case. The use case, I will leave it. But like as mentioned, Internet of Things. Internet of Things. Edge computing empowers factories to monitor machinery in real time. Now, in real time to do what? Yes, you monitor them to detect anomalies, maintenance alerts, etc. All that is needed to be done at the right time. That is real time. So what are you looking for at real time? You want to know whether it is time for maintenance. Yes, the system should monitor and give you a feedback. So we have that of Internet of Things. That is application of computing, edge what? Computing. Application of edge computing. We can also have it in the world of medicine. Telemedicine is one of the applications of the mobile edge what? Computing, which is actually a subset of cloud what? Computing. Now, we have autonomous vehicles. Today, we have cars which they claim are driven by themselves. And they rely on edge computing to process sensor data instantly. To avoid, if it is self-driven cars, you have to avoid accidents. And then also to navigate complex traffic scenarios. Those of us who have been joining Uber, sometimes when the Uber driver, those who are curious will know, sometimes when the Uber driver switches the phone on, you see some part red, some part yellow, some part green, as we have in the traffic, how do you call it, colors. So the driver can look at it, and the system itself sometimes look at when you start to charge. The system actually compare all the possible routes, look at the worst one, and that is what is used in charging. So you know offhand how much you pay if you, how do you call it, go through the hardware. Actually, you don't know how they calculate it, but you'll be given the amount. And when the driver comes in and switch on, you'll be seeing some part being red, telling you the traffic there is very huge. You see, all these are connection with some sensors, connection with the network, reading from the system, yes. And it gives you a picture and give the driver also a picture. Fine. Sometimes you'll see that as you go in, you know the route from where you go, but then the system will be telling, well, so you can take right and go. The system will say, go left, go forward, turn right, and whatever. So autonomous vehicle vehicles, that is the use case. Self-driving cars rely on edge what? Computing to process sensor data at a real time, that is instantly. Now you talk about smart cities. In smart traffic management, which is also another big area, smart traffic management. These are found themselves in smart cities, highly loaded, etc. Edge computing actually optimizes the traffic light timings. And it does this at real time. You see, you need it. Sometimes, let's take it this way. You'll be watching TV. Let's say Chelsea and Cherry River are playing. You are sitting in the midst of TV sets. You come to realize that set A will give you the value before set B. So when set A has already made you to say it's a go, you see the set B now telling you, yes, he's moving, he's moving, he's moving. So there is some differences. All those things. What are the causes? Fine. That is not what we need to talk about. We are talking about real time. So in actual fact, when we come to edge computing, we are most concerned with, how do you call it, real time. Now, content delivery and streaming, we know what it is. Games, etc. Imagine playing a game or watching a game and there's delay. It's an interesting scenario. That is, you have to minimize what? Latency. Telemedicine. You see, in telemedicine, what it entails is, yes, let's assume, or it is happening. You go to Kolebu, we claim to have the specialists in Kolebu. So let's take it that in a particular area, we have just one doctor in the system in that area. Now, an operation, and that person is possibly maybe resided in Accra, Kolebu. And there's an operation going on in Kumasi, which should go on in Kumasi. Instead of he traveling, he can just sit in Accra. In fact, it's a worry. I'm using Ghana, but it's a worry because in our system here, due to Doomsaw and all those things, anything can happen. So I don't think we are practicing that. But generally, what it means, using our own scenario, yes, one doctor or whatever, the specialist sitting in Accra and the operation is going in Kumasi, yes, they can see each other, talk to each other while the operation is going on, and he sits and directs, do this, do that, as, how do you call it? Those in Kumasi are actually doing, stitch it this way, do it this way, do it that way, and then they come to an end under his supervision, his guidance from remote. He's doing that from, how do you call it, remote. Doctors can remotely diagnose patients and provide immediate medical guidance. So remotely. Well, we are getting there. Soon, I believe. Those in power will see to that. They know all this. It's unfortunate. Where we are, we will get there one day. Where somebody will sit, you don't need to travel all the way from those of you who know Central Region a bit, to travel all the way from Chifupraso to come to Cape Coast and Tibet to get attention or whatever. Meanwhile, you come in and the doctor says, it's just some minor something. And then you could have sat there to avoid the insurance on vehicles, sitting in cars, whatever and whatever. And they'll get treatment from the specialist sitting here with the help guiding the doctor over there to deal with that. Industrial automation and robotics. In the manufacturing world, this is very important in terms of edge computing to manage robotic arms, conveyor belt. Of course, today if we are talking about telemedicine, yeah, the world is getting to a stage where even operations they claim is robots who should do it, and they should be, what do you call it? Smart. They should be smart, real time. If it is AA, yes, bring blood. Introduce this, yes. So in manufacturing, the edge computing, robots collaborate with human workers for higher productivity. The retail, customer, agriculture, yes, I agree. You know, IoT is there seriously. Energy management, etc., etc. There are quite a lot, but try to at least hover over them, read them, and get. Now, what is here is inclusive. They are more than this, but these are the common ones being used. So we looked at the common areas. We've looked at the common areas associated with it. Looking at this, there are 3 to 1 main point which I want us to acquaint ourselves with. In the industry or whatever, or all this that we are talking about, how the edge computing is operating in it, there is one word or 2 words with a hyphen: real time. Real time. In all what you are doing, the data processing should be what? Real time. And that is the main idea of the edge computing. Any question up to this point? So, as we started last week.
Hello, sir.
Yes, I'm listening.
Can there also be that a doctor can be in UK and then telemedicine to
Exactly. I see, when I started, I made mention that let me use Accra and Kumasi. And in order to diffuse the mind that is possibly there, I made it to understand, due to doom so, it is, how do you call it, an area we need to be careful with. Due to, how do you call it, doom so. It's an area we have to be careful with. And I don't think it's being practiced here in Ghana now. You see, in some of these, you have gadgets in place. The man sit there, you sit, it's at the theater, you sit. There are, how the screens there. You see the man, he sees you. Yes, he could point at, how do you call it, deal with this part or whatever. It's happening where you have 24-hour power system. I hope you understand. He who asked the question, all I want to tell you is that it's possible it's not happening, but it's something the whole world is looking at. The whole world is looking at. And hence, the reason why the world in the early 1990s forced that all countries should go digitalization, which Ghana started in the 1990s. And by the early 2000s, we were part of the digital world. So he who asked the question, yes, the answer is you don't need to be carried from here to US. You don't need to be carried from here to Japan. Yes, and the world is a village. It doesn't mean the doctors in US know better than the doctors here. It doesn't mean the doctors in Japan knows everything than here. No. We share. The world has shared it. The world have shared the intelligence. God have shared it and have distributed it. Unfortunately, some are making use and some are not making use. So he who asked the question, the point is that yes, it is happening, but currently not. And if we get ourselves into it, yes, a doctor sit at UK, operate here. How do you call it? A specialist sit here, and then how do you see to an operation happening in the US? I think that point is clear.
Yes, sir.
Okay. So we currently dealt with Unit 2. For your quiz, I believe you've made, I don't know what they did tell you, but I don't know if they did tell you that it's 6 units. And as such, for your quiz, which is coming on, you deal with 3 units. Am I right? Madam Emily?
Yes, you're
Hello?
right.
I'm right here. Okay. So it means we have for your quiz, we have 3 units. Now let's start with Unit 3, which looks at the application of advanced mobile computing and the internet. Now, when we come to it, we have gotten various forms of computing. Various forms of computing. Hey, hey,
John
hey,
Peters.
hey, hey. Hey, very interesting, eh?
John Peters always does that.
But Mr. John Peters, Mr. John Peters, yes, how can he even hear me when he's in the midst of entertainment? The man is in the midst of entertainment. Wow. Periodically,
That's
he,
incredible.
periodically he opens for us to do with the boredom, right? And bring our spirit back. Hey, John Peters. So currently, I don't think he's part of it. So he's just connected and he's enjoying some music or whatever. Well, let's go. Let me do my business. Let me mind my business. Now, in computing, along the line with networking, you learn something called, how do you call it? Topology. You learn something called topology. And I believe we all know that when we mention topology, it has gotten 2 main components, where one of the components is the physical and the other is what? The logical. The logical. Now, if we talk about the physical and logical, or let's take the physical, we look at how they are arranged in a network. How they are arranged in a network. Now, here we are. As a result of that, we've come to some forms of understanding the meaning of some computing processes. We have here the great computing, the mobile.
Also, we
Yes.
can't see your screen. Oh.
Eh?
Yes, we can see the screen.
Okay, just a minute. Can you please see now? Hello,
No,
are you
please.
please there? Can you please
No,
see now?
please. Yes, now we can see it. Yes.
Okay. Now, if you can see it, here we have the units outline: mobile grade computing, mobile peer-to-peer and client server, sensor, etc. Here, while we're looking at mobile grade computing, that is where we start from, which is actually a distributed system. We saw the systems, we saw distributed systems. The grid computing is actually a component of, how do you call it, a distributed system. And this connects. Hello, are you there?
Yes, sir.
Okay. What does this do? It connects geographically dispersed heterogeneous computers. So the computers are scattered, let me say, across the globe. And these are part of what is called distributed systems. And they act as virtual what? Supercomputers. Now, what do? We have multiple geographically separated computers which work together for one goal, towards a common what? Goal. So what it is they are scattered in such a way that a job that we normally make one computer to perform, no, are performed, this comes in and they perform it, how do you call it, together. Now, computers in the grid, mostly, yes, whenever we mention computers, we are getting to a stage, I will not use computer, but I'll use a node. Can be diverse in hardware and then the operating system. And they are often connected via the internet or networks. Yes, there are companies which can decide that we are creating our own network, virtual network, and connect them to it. If not, you connect them via, how do you call it, the internet. And then utilities on use or idle CPU cycles and storage from various, how do you call, systems are what we make use of. So they reshare resources, there's a middleware, and they do non-interactive what? Task. Now, what is the middleware? Software that enables communication, that is all. Coordination and resource management. So when we talk about great middleware, all what we are trying to say is that they enable the communication, coordinate, and then also manage what? Resources. They control the node. There's a central server that manages task distribution and gathers resource. So when the tasks come in, there is, how do you call it, centralize somebody who says that, okay, you handle the leg, you do the nose, you do ear, nose, throat, you do, how do you call it, the chest, you do the internal. That is what happened. There is, how do you call it, a node, normally known as a control node, which see to that. And mostly, when you talk about great computing, yes, they are commonly used in the scientific research, financial modeling, and data what? Analysis. So that is where, now let's go into it. So we have that in place. We have the mobile peer-to-peer and client server, which is just like the peer-to-peer and client server networks that you did learn. There's nothing different over there. It's only just a small concept. So here you are. They are network of computers working together, as I have mentioned earlier on. They work together to perform a task that will be difficult for a single machine to do. So here you are, like we are saying, in most research work, is teamwork. In the scientific, most often teamwork. And this machine on the network, they have the same protocol to act as virtual what? Supercomputers. Virtual supercomputers using the same one protocol. Unlike others where you can have different protocol, but you have a common one interfacing the different, how do you call, protocols. All they do is, as I've said, on the network, they contribute resources like processing power, storage, etc. So here we have, and then we have quite a number of them. I've already mentioned a grid computing network consists of 3 types of machines. Yeah, I mentioned how they got the control node, which is more or less the administrator. More or less the administrator. It acts like a central server and manages the task and also gathers what? Resource. We have the provider. The computer contributes its resource to the network resource pool. And I believe you know what a pool is. Yes, it is there. Whosoever need it, you go in and pick it and use it. The user computer that uses the resources on the, how they call, network. So in this, in common use, like I said, yes, it's for scientific research, data analysis, and mostly financial, how do you call it, modeling. Yeah, with regard to middleware, we have mentioned all this. So in a nutshell, while we have grid computing involved in distributed resources, grid computing is generally decentralized, application-oriented, and often used for massive, specialized batch task, specialized task, whereby one head is just like saying that 2 or more heads are better than what? 1. Yes. And I believe when it comes to the research world, 1 head, sometimes we tell ourselves, oh, I did it. I published my paper. I did whatever. Yes, you. However, there is a contribution from somewhere, from somebody, which goes into it. And yours was possibly based on something. So in short, cloud computing is typically centralized. Take note of this. Cloud computing actually is centralized and give a centralized service oriented and offers high scalability, unlike what we have just looked at. So comparing the two, yes. For the origin of grid computing, I wouldn't want to talk about this history. Possibly, yes. I don't think. Yeah, maybe I'll ask some. How do you call it? A fill in the blank question on this. Something I'll waste time on it. Advantages. In all this, we have advantages and disadvantages. So basically, all what I want students, or I always ask students to do is anything that we treat, take note of what I'm going to give you. You may write or may not. 1, you have to know the definition. Definition. When you get a definition, then you go to what is. So for example, we are talking about grid computing. You have the definition for grid computing. What is grid computing? We look for the advantages and disadvantages. These 4 things should be part of you in anything that you do. The advantages and the disadvantages. So talking about the advantages here, we say it is not centralized, as there are no servers required, except that centralized somebody called the control node. You see, the control node, as we see it, it manages coordinate things and whatever, but it is not like servers where we have a server sitting somewhere. It have gotten all the information and we all ask for. We go in, ask for that information and the servers. It is not. It is more or less like administrator. Now, multiple heterogeneous machines with different operating systems can use a single grid computing network. Yes, here we are. I don't think anyone have bothered to find out. Today, when you take the telecos, take MTN, yes, they are there. We have our machines I'm using Android, you are using iPhone, another is using Windows, etc. These are the base, different architectures, but we all get connected to it. How does it operate? It have gotten an operating system which understand all the operating system we are putting on. So whilst your machine is using Unix, my machine is using Windows. Yes, we get to a system. The system have gotten a network operating system. So in our case, we have the local operating systems. We have the local operating system. But then over the day have network operating system. And you understand, you all know what network is. Interconnection of at least two different. So here it says that multiple heterogeneous machines. Yes. What does it really mean? They have different operating systems. Yes, sir. They can use a single great computing network. As a result of, how do you call it? The node controller being able, or the control node, having the capability to understand all of them and then interfaces them and deal with them. Of course, you and I know that we have, how do you call it, operating system. What does it do? It how do you call it? Brings the software and the hardware into play. Fine. So as it's sitting in between, the software thinks that everything is software, and the hardware also thinks that everything is hardware. But then there's the operating system which converts the hardware to be to the level of understanding of the software, and vice versa. So you don't see it. Yes, here it is. You don't have the, how do you call it, the node, the control node, sitting there as an administrator, coordinating, controlling, and dealing with what. Tasks can be performed parallelly. You can, how do you call it, perform parallel across various physical locations, and the users don't have to pay for them. So we go on to, how do you call, here you are with it, as we mentioned. Here you are, like I use, you have the Linux, Windows, Ubuntu, etc. And this one, make sure that whatever they are doing, they understand. So this one would think everybody here is Windows. This one would think everyone is Ubuntu. No, but that is not it. You can use various heterogeneous to deal with that. Now, as much as we have the how do you call it, advantages, I want you to enjoy the disadvantage, but I'll leave it to you because there's this link here. Go and read on this link, and then it will help you. So with the result of this link, you can know that the control node, as you look at it here, is very interesting. If this one should go down, what happens to all of them? I think it's something you know. And then, having done the star topology in terms of networking, you know, in the star topology, they all pass through a central hub. And one of the main disadvantages, once the central hub is down, everything ceases to operate. So you ask yourself, looking at this architecture here, with this man sitting here and then making sure of either translation or transformation, what happens when this one goes down? So it's one of it, but I want you, that's the main thing I normally try to, see, trouble in the control node can come to halt in the whole network, yes. However, I detail you to read on this as soon as possible, and then you will see what goes into it. Madam Emily, are you there? Hey, hello, are you there? Are you people there? Can you hear me?
We can hear you loud and clear.
Okay.
Yes.
So here we go. We have, kindly read on this. Just click it or type it and enjoy it. And you get to understand all this. Licenses across many servers, they make it prohibitive for applications, etc., etc. In short, mobile grade computing, as I mentioned, is a subset of course, the word mobile here tells you we have great computing, but now we are talking about mobile. And when you see, whenever we come into mobile, one thing you and I know, we are in the wireless world, and what happens? Location. You see, relocating in terms of mobility. We expect that wherever you are going, you go with your database, you go with it. What I'm trying to say is, if you open your bank account in Cape Coast here, or yes, in Cape Coast, fine. When you are living here, wherever you go, it follows you, because wherever you get an ATM machine, when you go there, you can do operation to see how much you have in your account, whatever, all those things, your information or whatever, you can access them remotely. Meanwhile, you did it in Cape Coast, but you are now accessing it as Zuarungo, etc., etc. Mobility is actually, but once you hear mobile, then of course there's that component of no mobility. So we have, it's a subset of this, and these are all, they are part of the distributed what system, distributed working, and they work together to tackle task which one system cannot actually do. Peer-to-peer, peer-to-peer. We all know this. We have peer-to-peer or client server. Now, in peer-to-peer, we need to understand that we are all equal peer. You see, and we are distributed. We are still in the distributed world. We have ourselves scattered all over. But then, information is not in the head of one person. Information is not in the head of one machine. So these machines are scattered, and whatever information you want, yes, when you put it on the floor, all those who have the knowledge will contribute to it, so you can easily get it. Unlike the server, where we say everything is sitting on the server, so you have to query, go there, get it, it sends it to you. In the case of peer-to-peer, we all know, as we treated it, it's not different from what we did in network computing. However, in this case, you and I shouldn't forget there is somebody here sitting here called mobile. So whereas that we have immobile, we have mobile, and you and I know the world today is mobility. So we talk about how do you call mobile, peer-to-peer, and client server what computing. So let's go on. In how do you call it? Generally, as we mentioned, there's no server sitting somewhere, or somebody is centralized somebody. So it is more a decentralized wide model. And the individual devices, which are more or less referred as peers, they communicate and collaborate directly with each other, rather than relying on a central server. Information are scattered around. Fine, if mine get missing, you have it, I'll get it, and so forth. Each device has the potential to act as both a client and a server. Yes, you have a certain information with you that I don't have. So as you have it, when I request it, you serve me with it. You see, in the world of serving or server, what does serving means? You go to a restaurant and you say you want, they tell you, we have everything here. But you'll be surprised that there are items you will request and they say, oh, we don't have it. So they give you what is available. They serve you with what they have. So a server serves you what is, if it hasn't gotten it and it have got the link or the capability to ask other servers that it knows, yes, it can ask them for it, and then it passes through it and come to you. What we're saying is, since you have some information that I may not have it, that I will ask and you give me, you have it in service. So you are a server. I mean, a mini server. And at the same time, you are also a client. So we see both, we see each and every one on the network, in that network, peer-to-peer, how do you call network, computing system. What we have there is that everyone there can be a client and can also be what? A server. Let me see. Okay. So you can be a server when you have something that I don't have and I'm asking you. And you can also be a client. In this case, each and every one of us can be both client and server. And we share resources and services with other services on the network. Typically, these nodes that are equal participants in the, how do you call it, in the business are scattered around, and tasks are equally divided between. You see, the task is such that it's equally divided between all the nodes, and each of them interact with other as required. Characteristics is no different from what you've learned already. The different characteristics of here are as follows. What are they? They are usually formed by groups, and most often this is used, as you know, it is used when you have quite a low number of nodes involved, typically 10 to 12 or so nodes. You see, when it is big, huge, it doesn't work so much. So as you were told in the networking class, when you talk about the peer-to-peer networks, they don't take much nodes. As I said, some 12, 10 downwards. When it goes beyond that, it is not easy for it to what? Function. They use resources and provide resources, as I've said. Yes, you are a server and you are, how do you call it, a client. So you use resources, and then you also, how do you call it, give out resources. They both, as I said, so here you are, look at it, a modern operating system such as Windows to implement peer-to-peer, here you are. Yes, so whatever the information, you don't have somebody sitting at the center. Now let's quickly go to, you have the advantages and disadvantages. You quickly look at advantages and then what? Disadvantages. What are some of the, what are the advantages of peer-to-peer system? What are disadvantages? So you look at it. I leave that part to you. Now you come to the client server. As I've already mentioned it. When you talk about the client server, it says there's a server and a client. You go to the chop bar, you're a client to the chop bar. Now, what they have available is what you go in for. So you go in. Do you have fufu? No. Do you have cassava? Yes. Do you have this? What is available is what? What they serve you. They cannot serve you what they don't have. So are all servers on network. What is contained in them is what they can serve you with. If they don't have it, look, there are some chop bars you go in. So I want watch, we don't have watch. Anyway, is that the only thing you want? So give me some drink. I say, okay, hold on. We have a sister, how do you call it? Bar, who deals with watch. Will you mind we buy some of the watch for you? So no, so they go in or they call for watching from that one and serve you in a place where there's no watching. Yes, servers interact with themselves and serve, how do you call it? So you have client server. Yes, there's a client who usually, how do you call it? Query. He has got nothing. He queries, and then the system brings it. What does he do? To do that, you use the HTTPs, the FTPs, etc., to deal with the application layer and whatever. To do that, here you are. In the case of, how do you call it, client server, the server city is the one having everything. So you access here. For instance, to digress a little, let's take our yahoo.com. The server is sitting here. We are putting everything on it. This is sitting in the US. You are in Africa, in Banjasi here. Whenever you want to access whatever you did, you say your mail. Whatever information is in it is sitting here. So anytime you want the information, you have to go to US and come back. You have to pay for it. You go, so you see, courtesy internet, some of us have been to US without knowing US. You go to US and then bring the information. When you finish, you save and it goes back. Now, when it even go back and you still want some information that you have forgotten, you call it, it come back, you query and come back. So here we are. We have the client what? Server. Yet I've got advantages and then disadvantages. And what are the rules of the client and what are the rules of the server? I've mentioned it. The role of the client is always to query it. If this is what I want, give me this, then it looks. If it hasn't gotten it and has got a link to another server which has it, it will call for it through this and come to you. So as you sit here, yes, even if you know this and it comes to it, it is not always behind it, you will not know what is happening, etc. So what are the clients? They initiate the request for the service or resources, manage the user interface, may perform some processing work locally. After that is a server. They listen for the response to client requests. The servers are always sitting there waiting for the clients, and then they give them manages and control access, execute businesses, etc. It have got advantages and disadvantages. I will not talk about them. You read on them. Nevertheless, you have questions from them. You have questions. So we look at how do you call the client server? What is the advantage? What is his disadvantage? The peer-to-peer advantages and is how do you call it? Disadvantages. Now, in this, as we've mentioned, client server. So let's look at a little bit of types of service. We have the file service, we have the database service, web service, application service. These are the basic ones, but there are other services which are, how do you call it? You don't worry your head so much. If you want to go into go into it. It will help. Don't worry yourself for my sake in terms of examination. If I will even ask at all, maybe I'll ask one of these. File service, what does it do? It manages and provide access to files and storage, good, and etc. So here you are. Okay. Security. You see, it's very funny, where we have gotten to under this globe. I just used, how do you call it? Your yahoo.com, your gmail.com, sitting outside the continent of Africa. And some of us, all our pictures are there. Very interesting. Some of the pictures are wanted pictures. Some are also not how they call wanted. So we have a lot of pictures there, and especially these our sisters who term themselves as what did they call them? Something queen. Whatever queen they call themselves. You see, they have their picture. Slave. Good. Some of them have their pictures, both clean and unclean pictures. They have them there. And very interesting, these things as we are talking about, they are actually stored on a system sitting somewhere. So what about if there's those people there decide to cut us off and then try to go into, how do you call it, into it? What do you see? What do they see? So as we speak, very interesting, we are sleeping somewhere. We have our files, our information sitting somewhere, which we don't have control over, but is being controlled by, how do you call it? Security is an issue. How sure are you it wouldn't leak? You see, however, in all this, we are talking about this name, security measures, looking at authentication and authorization followed by the others, are crucial, are needed to make sure that authorized clients go across, access server resources. Now, in all this, when we take the OSI layer, fine, with the internet, we talk about the TCP IP model. Over there, we have the 4 layers, and one of them doing encryption, etc., to secure it. We know the encryption, how they call different basic forms of encryption, symmetric and unsymmetric, etc. All those goes into it to look at it. Hey.
And symmetric.
Uncle Bernard. Uncle Bernard.
Yes, I was.
We are hearing your voice.
Oh, sorry.
So the business you are doing, we are hearing all. So security is very, very important. Now, these systems, the cloud or distributed system or whatever, they are highly secured. Secured. The security in place is not easy. Even though under this globe, I've been telling people, even human beings sometimes get stolen. Some human beings vanish. Some human beings, you don't see them, they steal them, etc. So how much more machines? What God has created, the wicked ones are able to tamper with how much more what man has made. So in all this, having mentioned this, we look at how they call it, the advantages and disadvantages, challenges, etc. Have various challenges associated with them. You see, why? Day in, day out, human beings are giving birth. Population is increasing. Clients are increasing. As a result of that, we need to, how they call it, scale. That is scaling, expanding the what? The system. Now, scaling the server infrastructure is actually an issue. It's not always that you just go in and compatibility works. No, you go in, it's an issue. And it's solely all this, what I've been telling students, when you take the distributed and all this, they all rely on, how do you call it, network. They are dependent on, how do you call it, network. They are dependent on technology. So if the technology fails, what happens? If the system goes down, what happens? Some 2 years, 2 years ago, yes, due to the carelessness or the, well, I will not tell you it's careless. They know what they do to steal from us. Today, the networks are stealing from us heavily. Yes, some of us can go to court, and instead of becoming rich, we'll become enemies. We'll be threatened in the night. Instead of the case going on, yes, politics will come in, and then you see. Today, I make a call. I'm making a call. Look at how I struggled some few minutes ago to get you connected. Now, it has stabilized. Who knows what is ahead? Today, you take a phone to call somebody. Yeah, they are deducting the money, all right. The contract is that you sign a contract with the telecos or the service provider. I will give you my goods to send via electronic and pay you. He takes my money offhand. He takes it. When it is time and I try to deliver my goods, I'll be online and it will go off. Sometimes I'll be online with the person, hello, hello, hello. Either that person is here and I'm not, or both of us cannot hear each other. But what is interesting in that is that in all this process, the money is being deducted. So you are paying for unused what? Service. Very interesting. So here we are. All we say is that the peer-to-peer computing is how they could decentralize, whereas the client server is how do you call it? Centralized. And they are all fundamental architectures in modern computing. And most often they form the backbone of the various networks. Yes, they are certain that at different points. They are the backbone. Whatever it is, that is where it's either stored or where it's sent to for processing, etc., etc. Any question up to this point? Now, if not, we'll have to jump to one interesting area. Very interesting. And with that area, we talk about the name itself, to sense. To sense. What is it sensing? Very interesting. Like the dog sniffing around for an animal. Now, in this case, we have infrastructures as of some form of battery-powered systems, and basically they are all in the form of how they go distributing a network. So we have distributed devices, and they collectively monitor physical or environmental condition. Some of them, for instance, let's go to the hospital. We have the thermometer set there. They sense temperature. We have those who sense sound. We have those who sense motion, images. And in all cases, we have nodes which do that. Now, in our case here, what we are looking at is a mobile sensor networks. Mobile sensor networks. We have nodes which are actually wirelessly connected. They collect the data, transmit it to a central base station for analysis. So we have various forms of them. Fine. Some of them, mobile sensor networks. Today, you have your car remote. You'll be moving around while you are switching your system. You have, how do you call it? Alarms, etc. You can stand somewhere today. You can be on your phone elsewhere and see what is happening in your house. You see, so we have nodes involved. Now, with these nodes, I'm trying to let you understand that we have the sensor networks, which I've mentioned. However, you and I are looking at mobile sensor networks, mobility. Mobile. We are looking at mobile sensor networks. You see, when mobility comes in, all it means is that there are additional software required and there are additional, how do you call it, hardware required, you see, to make the system work as expected. Now, these nodes, as they move, so the main components of this, we have sensor nodes. Sensor nodes. We have sensor nodes. Now, when we talk about sensor nodes, this comes together to form the mobile wireless sensor network. And it is normally defined as network of sensors with movable platforms. And this can be deployed in challenging or hazardous environments. Let you and I look at a bit of this scenario. You are in your room. It is in the night. You forgot to lock your car. You need not go down. Who knows? At that hour, who is waiting to, how do you call it, to deal with you, or waiting for a prey? You don't know. But with that, you can sit in your comfortable zone and then lock the car from that point. Now, in the case of mobile, what it is that the nose consists of a radio transceiver. Fine. You are talking about, let's say, your car alarm. You always send, or your TV, you always send. But then, so you look at it from a way where we will say it is simplest, one way. But don't let you and I forget that the sensor in your remote and the sensor in the TV, they are always communicating. You don't see it, they communicate. You see, so in a nutshell, what are their applications? Environment monitoring, surveillance, and they, as I said, they have gotten, how do you call it, radio transceivers, microcontrollers, battery, which is very, very important because you are moving with them and you cannot easily access the, how do you call the AC currents. You always need a battery. And then, depending on what you are doing, we have sensors for detecting light, heat, humidity, temperature, pressure, etc., etc. So in a nutshell, let you and I go to, how do you call it? Let's say even the hospital. Most of the devices they are using, they are all ITAs. No medical doctor. Yeah, we are getting there now. Gradually, we'll get there. Some of them will. But no medical doctor manufacture any of their instruments. The instruments they are using today are all, how they call, built by the electronic engineers. So the electronic engineers basically will even have to know more of the medical condition than they themselves. You see, you have the electronics and IT engineers coming together to deal with all this. Fine. You have scanners in the hospital. These scanners, what do? They sense, how do you call it, the human body and transform. They say transformation. It transform whatever is happening into images, which the system picks and then deals with it. See? Hello.
Hi.
Oh, okay. So when you talk about sensor networks, the sensor node, in this case, the sensor nodes are mobile. They are smaller, and as I said, they are much more versatile than the static sensor networks. So like I mentioned, yeah, they are not different, but there are slight differences. Whenever mobility comes in, there's something in addition to take care of the static. So having mentioned the humidity, temperature, and etc., let's go on to look at what are their characteristics. Here we are talking about mobile sensors, so it should be mobility. Sensing, it is expected of them, and as a result of that, they are equipped with various types of sensors. Those which can, how do you call it, sense light, those which can sense heat, etc. and etc. Now, one of the characteristics is also that wireless communication, like the traditional ones, This rely on communication, wireless communication protocols. Yes, I believe for now the protocols I will not talk so much because you haven't done how do you call the OSI model and the TCP/IP. I expect that that component of the functions of the layers and then the protocols involved. Let's look at a simple way here. What I'm doing now with you, if I'm lecturing those from the deaf and dumb, it will not work. How do they? They will not hear me. There is a way to do it. And that way should be understood by both the sender and the receiver, and as such, there should be some, how do you call it, rules, regulation, and instructions, which we all have to. So you have the wireless communication, protocols involved for exchange. You have the dynamic topology. The network topology is dynamic because it's moving, unlike the previous one, which is static. Applications. I've already mentioned quite a number of, how do you call it, application already, taking into consideration environmental monitoring. In the world of agric, today they can use to monitor crop health, soil sciences, etc. And for military, don't let us talk about it. Military and defense. We have smart transportation, wildlife tracking, not car tracking, and wildlife tracking. Today, you go into the system, they have these animals. Once they grab them, they try to find a way of inserting, how do you call it, a sensor into the animal or the fish, put it in the wildlife or the sea or river, and as it's going, wherever it is, whatever it's doing is being tracked and recorded. In everything that we are doing, in all or whatever we are doing, we have challenges. There is nothing under this globe created by man that has got no challenges. As we mentioned earlier on, it doesn't rely on AC, it relies on DC. So using the DC system, you need a battery. You need a battery to store the what? The power required. Like some of us here, when we are moving, we carry power banks. We carry power banks. So we have this, and we look at the challenges. As you are moving with the device, there are two things. And as those of us here who are with the IT system knows, there are two main things, hardware and software. Yes, when you get into each and every one, it's broad. It's an area of the, but then categorically, we have, how do you call, hardware challenges and then software challenges. We also have environmental what challenges, where you look at the medium through which you are transmitting, varying topology, etc. All this goes into it. Now, in your networking, you know of something called hops. For instance, the signal traveling from here to, let's say, from LMUs, the air to satellite. It is passing through layers. We have the stratosphere, which have got its own characteristics. It goes on and on and on and on to the ionosphere, where you have various, and it goes. Now, the higher as you go higher, you know what happens. The cooling system becomes higher. The signal you are sending, you process it in a hot condition on Earth, and it is going via the satellite, and it has to pass through the layers to the satellite, which is about 36,000 kilometers from the Earth station. So you see, in the mobile world or the wireless world, the sensor nodes are said to be autonomous or remotely controlled, but then they pass through different, how do you call it, layers. So environmental. So we also have environmental effect on them. Even that, let's take even just the TVs and others. If those of you who have been reading or those who have been following, you come to realize that when you take a TV or even your mobile phone, it have gotten a minimal temperature and a highest temperature range that it can perform. The range that it can perform. Whenever I get to this area, I remember Kudaki in some wild clothes taking measurement in Siberia. Very interesting, eh? Sometimes I sit and ask myself, how did we do it? Yes, you have to know the temperature range so as to design the transmitters and receivers to be able to work in that zone and also work in, how do you call it, tropical zones. So you take them. It is just like I was some few days telling somebody that the temperature in Dubai, the person was shouting, hey, temperature in Ghana is too hot, oh, we need to go abroad. I said, will you want to go to Dubai? I say, yes. I said, do you know the temperature in Dubai? You go there and see. Beyond Dubai and that Saudi Arabia land, where you have the desert, and you see how you enjoy the temperature. So it's not true, it's not true. I said, okay, don't worry. Today we have the Google, so you go. We don't talk, go. And see, the environment is a factor. Some of us don't know, but let me bring it out at this point. When it gets to Hamatan, you see that the systems struggle to perform. If you have noticed, in Hamatan, TV, whatever, the systems, because the wind blowing have got a, how they call it, environmental factor, which actually disturbs the, how they call it, equipments or devices. Any question up to this point? Any question up to this point? Now, if not, we have been measuring equipment, devices, equipment, devices, equipment. And don't forget, we have got network managers. We have got network managers. What they do, they manage the network. And like I mentioned, when you talk about topology, you have the physical topology and then the logical topology. What goes into the logic? The logic, more or less, is configuring the systems, managing the system. Yes. How the system routes, you create different forms of what? Routes. Now here we are, we have to look at the distributed data management. Distributed. Yes, we say distributed. You have the nodes across the world and the information is distributed. In actual fact, you and I, what are we interested in? We are just interested in the data and then the, how do you call it, information. We are interested in the data and information. Now look at it this way. Let's take money. Some are dependent on others. Those who depend on the others, all they need is the money. As to how you get the money, is not important. As to whether there's money in your pocket, is not important. What is important is you want the money. So how is it managed that we get some for them? How is it managed in the distributed system? How is the data managed that information, how do you call it, gets from one point to another and not misdirected, and transaction management? So here we go in to look at distributed data management. What does it look like? What does it look for? What does it look for? It's actually looking at the efficient control. You see, you ingest information, data into it. When you take what we are doing, we say a computer is an electronic device that take an input, process it, and give out, how do you call it, information. So here, there is one thing. It takes input. What is the input? The input is basically data. It's basically data. Now, when you process data, what comes out is information. Now, it's not every information which is information. You take cassava plantain, you pound it to get fufu, which you want, which is the information. The cassava plantain are the data, the input. All the accoutrements in which are used, the water, the pans, the free, the heating system, and etc. They cease to the processor. Now, after processing, you get the fufu. But the fufu is full of balls, something you will not take. It is not information. It has not been accepted. See, so what we're trying to do is that we ingest, we put data in. Now, after processing, whatever comes out, we either send it or store it. We also have to maintain the system. The maintenance of the database system, the management of all those that are involved is what we are talking about. So even though we have mentioned, we just mentioned, the cloud computing, those things are sitting somewhere, whatever. Are they managed? If they are managed, what goes into it? You see, the distributed data management system actually coordinates storage, it sees to access, it sees to the administration of the data across multiple geographically. We say the systems are multiple geographically located. So it look at all this from that point of view. It allows users to manage remote files as if they were closer or local. So you see, as I said earlier on, some few minutes ago, I made you understand that when you have your Gmail account, as we sit here, our Gmail and then the Yahoo accounts are sitting on a server somewhere. If you don't have data now, you cannot access it. If you have the data and the system is, how do you call it, down over there, your own information, you cannot access it. That's where we have found ourselves. So it allows we, the users, yes, you call your file, they bring it from US to you on the electronically. You go, you delete some things, you add some things, you finish save. It then goes and save it in US. Wow, very interesting, eh? So what does it do? It allows the users to manage remote files and as if the files are local. So you sit here, work on it as if it's here by sitting at remote US. So while you are working on it, it is being, how do you call it, savings and all those things are going on over there. It enhances performance as if they were local. Enhances performance, scalability, and what? Reliability. Now, when we talk about DDM, which is distributed data management, it enables organizations to handle a vast decentralized data volumes efficiently. You see, vast. You see is in the cloud. And if you go on the cloud, a distributed system with the machines scattered over, the whole world, we are all putting information on it. So we can imagine, how do we manage it? Look, even with, how do you call it, the normal emails, sometimes you are given a space, storage space. You exhaust it, and they tell you, yes, you have exhausted it too. Either you delete all that is in it, or you come in, you pay some money, and we store them for you. You see, so we have in this, all what is looking at is what? Is effective data management practices required to see to it that the input of data, processing, storage, organization, and maintenance in the organization are actually done well. So we have some aspects, key aspects. We have some key aspects. You have the definition, you have the architecture, and you also have the components, which we have already mentioned. We have the nodes, we have the management system, what we call the metadata management, and data access interfaces. Now, these have got challenges, and they have also gotten advantages. So when we look here, we have the management, fine. Under this, what I will expect you to go and read on is, you have the challenges here. One of the challenges is that data consistency. To ensure that what the system should ensure that data remain consistent across distributed nodes in a major challenge. It's a major challenge. For instance, take the bank, let's say Absa Bank. They have their database, but it will also be good of them, or one best thing to do is they have to get, if it is storage, they have to get a redundant storage system. What does that mean? What it means is that instead of having just a single storage system, you have one, a replicate. So whatever you put on the main, you put it on it, so that tomorrow when the main goes off, the other one can take over. Or tomorrow when the main has a problem, after that, it can be, how do you call it, accessed. So it's just like having, how do you call it, a copy sitting somewhere. And we're saying that the copy should be consistent. So look at it this way. You come to, how do you call it, Cape Coast here, you access your ATM. Now, at the ATM you are accessing here, depending on how their network was designed, they can have a server sitting here. And whatever you are doing is on it, a copy. And they have a copy on the main server. You see, let me just get it clear here for us to get a picture. ECG. Any of our current people who tell you that we will never see, how do you call it, do so in our life. It's never true. We will always see Doomsaw when they are doing maintenance. Why am I saying so? They have gotten only one line. Elsewhere, where you have a 24-hour light, they have at least two lines, so that in normal condition, when they are not working, when they are all, how do you call it, working, you can make it 50-50. This carry 50, this carry 50. When one becomes 40, they offload everything, put it on the other, and then they work on this. When they are doing maintenance, they work, they shut down A, work on it whilst B is working. Because You cannot let the system be on and human beings working on it. So there should be always be what some will say backup, but generally it's termed as what? Redundancy. And as how do you call it? As a designer or looking at the distributed management system, you have to distribute it in such a way that when one goes off, somebody has the information. You see, so you have data consistent, and that information should be consistent wherever it is. If you have two copies, 3 copies, or they should be what? The same. What it means is that whenever you update A, the system should go and update all of them, either automatically or you do it how do you call manually. Data security, protecting data from unauthorized. Scalability, the ability to manage data efficiently. Data recovery, yes, this is where it is. When one goes down, the other has it. So implementing mechanism for data recovery in the case of what? Failures. So we look at that, and we also have to look at transaction. What we have looked at is distributed data management. Let's look at it from the fundamental point. What is transactional management? And in transactional management, you see, it involves the coordination and control of the transactions. And this should have the following principle. We have something called atomicity, consistency, isolation, and then what? Durability. Now, what are the key components? Transaction. A unit of work. It should consist of multiple operations. And it's either fully completed or fully rolled back in a failure. So when there's a failure, you should be able to have whatever. Currency control. This makes sure that multiple transactions do not interfere with each other, etc., etc., login, recovery, and you have the challenges here. I will not talk about it. I will leave it as an assignment for you. You have to enjoy some. Now, in all this, we are talking about types of transaction models. There should be models. And you will hear in the networking system, they will tell you this, oh, this is 2-phase, this is 3-phase, and all those things. They are also here. You see, some are to ensure that all participants either commit or abort a distributed transaction. Some also see that they have to put structures in place to avoid blocking in certain failure scenarios. So look at it this way. You have ECG and you also have a generator. What have you done? When ECG goes, the generator take off. So you have blocked that failure system. Distributed transaction coordinators, middleware, etc. Now, in these two, what does the two that we have discussed do? They are mechanisms which are actually, if you look at them, they are form of maintenance. They are mechanisms which seeks to maintaining the data integrity and also ensure that communication is reliable. Transactions are without failure. They should be reliable. There should be consistency. Security, wow, we don't leave it anywhere. You have what do you call it? Scalability. And there is one which is called fault tolerance. Let me mention this component to get a fault tolerance. How do you tolerate fault? We hear, oh, our computers are fault tolerant. Our system is fault tolerant. No, they don't tolerate the fault, but that is the language we are using. What it is that there's somebody there. When this one is sick, that person take over. So you can have a system where you have parallel components you may not know, parallel system in place. When one is working, the other is reserved. It's just like, fine. When there's doom, so those of us who don't have a generator, we see it as a fault. Yes, a fault has occurred. What is that fault? Some will tell you it's accident. It's not. It's a fault. It's being worked on. Then, but not until it's worked on, you are in darkness. Meanwhile, those who have generators, they have swapped it over to generators, so you don't see. And as such, they will tell you we are faultless. We don't have faults. We can never have fault. And the same as fault what? Tolerance. So they tolerate, the systems are built, and as we see them, to manage them or put them as where they are, you have to put in structures to tolerate them, to tolerate all those things, so that the system can work 24-hour without any interruption, break, etc. The way it started, it continued, how do you call it, 24, 365, and goes on and on and on. So over out there, that will be seeing power always, and it's not anything, it's not magic. It's simple engineering. Have a redundant. When there's a problem, that one takes over, so nobody see it. It's just like you and I today carrying power banks around. Yes, that fault which will occur, you see, when the battery goes down, it's a fault. It's not characteristics of it, so it's a fault. You instantly change it by powering it with your power bank, and you go on. So it is how they call faultless. It tolerates what? Fault tolerance in complex distributed, how do you call it, systems. Having said this, in all this, if you look at networking, there are two main points associated with networking. There are two main things. We have the nodes, which in some cases, especially when they are fixed, this and we tell them are switches. And we have the transmission mediums, and they are nothing like. You see, we have the road network. When you talk about the road network, for instance, go to Kufuor bus station. That is the node, it's a terminal. That is where you buy the tickets. That is where you get loaded. That is where they give the order the bus should take off. And then when the bus take off, it is on the road from Accra Kufuor bus to Cape Coast Kufuor bus. So there's an interconnection. So it is. In our case, we have the computers. When we have the computers, they are connected. We're using transmission mediums. These transmission mediums can either be guided transmission video or unguided. Once we come to the unguided world, that is where we talk about wireless. And in the unguided world, the medium of exchange is free space. So the wire, we have wire. The first generation of all this network were fixed, wired. So we use wire. Now, with the next generation, where we depend using free space as transmission medium, it's called wireless, wireless. So we have wired and wireless. Whereas wired is guided, it guides the information from source to destination. The wireless uses free space. You throw it into air, you don't know how it goes. Yes, except those who understand the game and know how their processes, how they are encrypted, etc., how they are routed, and all those things. So we look at wireless network. What does wireless network simple mean? You see, there's no way you can do mobility without running on a wireless network. Wireless is using free space. So you put those things in free space. And so let's look at here, we say wireless network, classification and Internet of Things. Yeah, what is a wireless network? I mean, I've mentioned it. All what you are doing is that you are connecting devices, which are devices, and these devices are connected using how do you call free, how do you call space. Now, in these types of wireless, we have got a lot of them. We have the cellular. Yeah, in the case of cellular, the telecoms operate using the cellular, and it is a wide area network. So the cellular deals with wide area network, and we know of the gene, 2G, 3G, 4G, and as whatever. The genes are used for high-speed data access That is all. As for voice, look, the integrated system today do both voice and data. Yeah, as for voice, it's like a pig. However, the road is dirty, it will pass through. So it doesn't matter. But data is highly sensitive to, how do you call it, to noise. So the cellular network, 4G, 3G, 5G, or as you are talking about the G, is only talking about the amount of data that can be sent or received in a second. Higher speed data access. Now, as the cellular network is, how do you call it, it distributes in the wide area network. So do we have the Wi-Fi distributing in local area wide networks. And we have what is called MiFi, the MiFi, which distribute in the metropolitan area wide networks. So we know of the 3 area networks. Yeah, Bluetooth, etc. They are PAN, personal area network, etc. We have the satellite networks with the station sitting on Earth, and then you have the satellite about 36,000 kilometers away from Earth. They communicate, send information, we process information on the Earth's surface, we give it to the satellite broadcasts it down, and all those under its coverage area will be able to receive the information, mesh networks, etc. Now, wireless network, it have got challenges, a lot of challenges. It relies on frequency, and the frequencies can be how they have what is called interference. So it the signals interfere with each other. Security, it's easy. Well, how easy it is depends on so many things, but it's easy. For one, I'm on my mobile phone, I throw the information into air. Look, just go up a little, take pieces of papers and throw them up. You see, they will get scattered. So my information that is coming out from my mobile phone is scattered. Who can intercept it? People, how do you call eavesdrop? When they eavesdrop, that is why they search for the hackers, the crackers especially. And then when they eavesdrop, they intercept it. When they intercept it, they can, how they can modify it. They can stop it from going. They can change whatever and send it. Scalability, managing, see, with wireless, the population is increasing, and managing a growing number of connected devices is also what a challenge. Now, as I mentioned earlier on, the wireless network can be, how they classified according to coverage area. So we know the LAN, local area network, is in building and offices. The man take care of about area of a radius of about 50 kilometers. And for wide area network, yeah, it's relative. How wide is your wide? Ghana is wide. West Africa is wide, etc. The whole world on the internet is wide. So it's relative. So we look at it. We have the personal, local area, wide area, the topology, you know of it, star and mesh, whatever. Purpose of public. Then you have Internet of Things, which you and I have been talking about it, especially in the world of agri. See, it's a network of interconnected device objects that communicate with each other over the internet. Actually, how do you call it? Confusing society. Now, the components of IoT are sensors. Take note of this. I will not listen. Sensors and what? Actuators. What is an actuator and what is a sensor? Fine. Connectivity, we know. Cloud infrastructure. Data is sent to the cloud for storage. Some of us, as I said, in the cloud, we have our systems there. Application softwares and interfaces. Now, IoT. We look at how they call IoT, Internet of Things, because here we are looking at what is the wireless networks, classification, how do we classify it, and Internet of what? Things. So to talk about the Internet of Things, we have mentioned it. What are the components? You see sensors and this. We've looked at the application. What are the areas? We know of agric being one. We also know smart homes, smart cities. We know industrial, agric, etc. So there are quite a lot of them. Smart homes, what is it? Thermostats, lights, security system. All this falls within, how do you call it, smart homes. Please, are you there? Are you there?
Yes, we are
Yes,
there.
Okay. Give me some 5 minutes, we'll run off and finish the game. So in the application of IoT, it have got challenges. Look, anything passing through free space have got, how do you call it, easy to intercept. If not properly, how do you call encrypted and etc., it's easy. So you have security. How do you protect it from these cyber cyber threats? Look, as you sit where you are, you take your mobile phone. Hello, don't call me again. You put it into it. And that thing is in the atmosphere, moving from your end to the end where that person can receive it. You see how interesting it is? Security. How can you guarantee the security? Take it this way. You send from your mobile phone, it goes to the edge. From the edge, it goes to the core. Let's take it that your information is going to UK. The core decide to use satellite. So you travel another 36,000 kilometers to the satellite, go down, etc. You can imagine the times involved and exist. Now, in any point in time, it can be attacked. So how secure is it? Scalability, managing the increased number of IoT devices and how it will interoperate, how the devices and platform can work together. It's all challenges. They are all what? Challenges. So we have challenges to that. At this point, let me just get you to, how do you call it, the last point. And some of the last point I've already explained them but I'll just touch on them. You have failure recovery. How do you recover from failure? Your system goes off. How long does it take to restore it? See, how long does it take to? So you have failure recovery. How do you recover from failure? Of course, failure can happen some years back, not quite long. Yes, during Atam Mills' time. Haiti, that country, had an earthquake which destroyed all its ground system except the satellite. So the world could only reach them via what? Satellite. Very interesting. Sometimes we even talk about satellite and just talk it. There are stations on Earth. So those satellite stations which are on Earth, what happened to them? They were also destroyed. But in the engineering processes, you make things such that, yes, there should always be a way out. So looking at what is failure recovery, looking at it in our context, it looks at the process of restoring a system to its operational capability. And this can come from a variety of sources, including failure as it is, can come from a variety of sources. Your hardware can go up down, your software can go down. There are external factors. Your phone have been stolen, etc. And this can disrupt system function. What happens? You have to identify the initial steps by looking at the system, detect and diagnose, that is troubleshooting. You isolate. In troubleshooting, you diagnose, you isolate the problem. So after finding the problems, what do? You correct them. And in correction, you restore it. That is the final stage where you restore it. You see? So after you've corrected your system, if it is a machine, you did put it off. Now what you do is that you restore it. And this stage, look at the process at which you bring the system back to its normal operation. In all this, you have what is called redundancy, as I mentioned. You should have a backup. Redundancy is like a backup. You see, ready to take over in case of a failure. Data backups. You know what it is? Saving and securely storing critical data to vital points. Most often today, what do we see? They actually come in to patch the software to deal with the bugs and etc. In what today you see, you'll be there, then something will come. Will you accept? They have to, how do you call, update or upgrade your system, etc. They goes in. Load balancing. Load balancing. There should be some form of load balancing. Like I mentioned earlier on, you take the, how do you call it? The ECG and also have a backup. So once ECG goes away,